Residual standard deviation is a statistical term used to describe the standard deviation of points formed around a linear function, and is an estimate of the accuracy of the dependent variable being measured. Residual standard deviation is also referred to as the standard deviation of points around a fitted line. The residual standard deviation can be calculated when a regression analysis has been performed, as well as an analysis of variance. When determining a limit of quantitation, the use of a residual standard deviation is permissible instead of the standard deviation.
Say what? Okay, what the heck was that all about? Well, we're just going to start off with the basic idea that he's just mentioned, standard deviation of the residual. Okay, so first of all, what standard deviation of the residual is represented by the letter S. And what does it do? The bottom line is it literally looks at the vertical distance of the regression line. So we know residual is the distance is the observed minus the predicted. So we're looking at the average or the typical difference between the residual, the typical distance between the observed minus the predicted. You also might see this in a multiple choice question waiting to happen, a typical distance from the data points away from the mean. And honestly, even though that's true, when I look at this, it doesn't quite work for me when I'm really thinking about what it means if I have to do an interpretation, which we'll talk about in a minute. But think about here, if this is your least square regression line, and then you have dots like this around the points, and then here eventually become your residual, those are your residuals, and as I take a marker that I don't have here, we know this is our residual, so I'm going to turn it this way. Oh, and that's tacky. I got to pull that together. Got to pause. There I go. So what this is doing is this is finding the average distance away from that residual line. So, and you know what's in purple was the old scatter plot. So when I think of an S, that's what I think, vertical distance away from the regression line. And next I have here the interpretation, which we're going to work with in a few minutes. So I'm just going to continue to move on to something else that is extremely similar to the standard deviation of the residual, which is referred to as R squared and specifically called the coefficient of determination. And you know R squared just means you took the standard deviation and you squared it. But what does it tell us? It tells us how much the least square regression line is predicted based on those values. So how much of the line explains the values of y? How much that regression line explains the response variable? Now, as I give you formulas for that, here's one formula, which honestly is just a multiple choice question waiting to happen. And we can see what's happening here, the sum of the residuals squared. And here, what's happening is we're taking each piece of data for the response, comparing it to the mean, which takes us to that, again, multiple choice question waiting to happen. And then we square it and take the sum of it. And we can see what's happening here, the idea of the vertical distance, because those are always the values of y. Okay, so multiple choice question waiting to happen. But bottom line is, when I think of R squared, I just think of it as the correlation squared. That's it. Next you have right here how we can interpret it. Now I'm going to jump over this. You can go ahead and write it down, but I won't be able to do an example on this one now. So you can write it down or you can wait. Yeah, just write it down. I'm going to continue to problem number 56 though. Okay, so problem number 56, hopefully you've read it. And yes, it says the scatter plot and the residuals below, but it's to the left of it. There's a better picture of this on page 195 and 196 of your book, so you might want to refer to that. I've drawn the residual line. Let's notice here, this line of best fit looks like this. If your question is, how do I know which one's the residual and how do I know here's the residual and this is the scatter plot? Well, there's two, not just the words, but remember your residual, that value right there is 0. And here's your residual is your old prediction line. So, but here's the original scatter plot, and let's look at these values. I mean, these points are just so vertical and so linear, unlike the dots that I'm putting there. So it stands to reason, as I slide this over so you can see the whole thing, that this is, once you make a residual plot, it is going to look like this. But then let's go to the next page and answer some questions about this particular graph. So the first question is, here's our equation, and we have our standard deviation of the residual. And I forgot to mention, this is also referred to as the standard error of the residual. So write that down somewhere, the standard error of the residual. And we have our coefficient of determination, our R-squared value. So they asked me to calculate and interpret the residual for a student who is 141 centimeters at age 10. So math mode for a minute, I am putting it as a point, and as I put it in the point, remember this is our age, and this right here is our observed or our actual piece of data. They want our predicted. So here I'm just going to take it and take that age of X and just plug it into the equation, and this is what the answer would be if it were on that prediction line. So go back to page 10 for a minute. So what we're saying here is at this age 10 right here, the predicted height would be right there. That is the predicted height. And yeah, am I off a little? Yeah, visually challenged at the end of the day, so it's better right there. So that is what the predicted value would be. But they have the observed value for us, don't they? Yep, they do. And going back to page 11, remember the observed height right here is 141. Remember, observed and actual is the same thing. So now they want me to calculate the residual. Well, here the residual is the observed minus the predicted, or the actual minus the predicted. The 141 came from here, the actual data that we have. The predicted, we did the calculation. That is our residual value. The next thing they want us to do is interpret it. And I use that rubric that I will be putting online for you guys, or the rubric that I put on the other page. So here, the student's actual height was 7.2 centimeters less than the predicted height given the student's age. And what I've done is the numbers that were, the words that are underlined was to fill in the blank of the rubric. So let's continue to the next question. Here is saying, is this linear model appropriate? And I know some of you guys are saying, well, it's not really scattered, Miss Yarbrough, but then we'd have to go back and look at the idea of what this graph looked like in the first place. And a linear model was reasonable as we looked through here. Not nice, but reasonable. So, for that reason, I said the linear model is appropriate given that there is no curve in the pattern and the residual plot. Okay, don't forget you've got to mention the idea of a residual plot, and I mentioned there was a curve. The book said this. The book said there is no leftover pattern in the residual plot. A linear model is appropriate. Okay, I like my answer better. And I think my answer is more consistent. Next, I want to interpret the value of S. They told us up here, where to go. S is 8.61, but what does that mean? Well, if you look back on that rubric on the other page, fill it in. So, when the least square regression line with the age, with X as being the age to predict Y is the height, we will be off by approximately 0.61 centimeters. Just plugging it in. And you don't have to use these rubrics. I'm just saying if you want a 5, a 4 or 5 on the AP test, this is what they seem to like. So it gives us a better chance. Now, part D, interpreting the value of R squared. Remember, R squared stands for our coefficient of determination. So, remember the coefficient of determination, our R squared, basically tells us how far our data is from that least square regression line. Okay, and as I look at this, it tells us also, in the words of what a true R squared represents, is how much of this line explains those points. Okay, that's generically speaking. In context of this situation, about 27.4% of the variation in height, and remember, here's your height going right here, is explained by that least square regression line given the student's age. So I'll do it again because I was a little off screen. Okay, about 27.4% of the variation in height, the Y values, is explained by this least square regression line given those ages down here. And that is what an R squared value is. Now the last thing that I want to discuss before we continue is, well, I kind of said earlier that how I've been talking about your R squared and your S, your coefficient of determination, and your standard deviation of the residual, which is also referred to as the standard error of the residual. It sounds like they are so alike. Okay, touche. So what are the differences, or how do they compare, how do they contrast? Okay, they both have the sum of the squares of the residuals. So they both calculate it. Okay, yeah, multiple choice question waiting to happen. What the heck does that mean? Well, what that means is they both tell us about how well that data fits the line. Okay, Yarbrough, that makes sense. Okay, but we know the smaller the squares, the closer the points are to that least square regression line. So we can see how that goes hand in hand. Now that's how we compare. The contrast is basically there are two different looking formulas. And one also, I would say another contrast that I haven't written down here, so I'm just saying verbally, is that one is looking at the errors. So the standard deviation of the residuals looking at the standard deviation of the errors, because isn't that what a residual plot does? It calculates errors. Whereas your R squared is saying how much of the line is explained. The line of best fit is explained, how much that line explains those different points. So S is based on the idea of errors, a residual plot. This one's based on the actual line of best fit, or let's go into stats mode for a minute, least square regression line. Okay, so ta-ta for now. Go do your homework.